Hi, welcome to LeetCode. In this video, I am going to discuss LeetCode problem 3478. Choose k elements with maximum sum. So you are given two integer arrays nums1 and nums2, both of length n, along with a positive integer k. So for each index I from 0 to n minus 1, perform the following. First of all, find all indices j where nums1 of j value at index j is less than value at index I. Then whatever actually we will get some index j or actually this first condition valid. So now we have to choose at most k values from of nums2 of j at these indices to maximize the total sum. So we have to return an array answer of size n where answer I represent the result of the corresponding index I. So let's see the example one, then it will be more clear what actually trying to say this problem. So nums1 actually is 4, 2, 1, 5, 3 and nums2 is 10, 20, 30, 40, 50 and k is equal to 2. So first of all our I is equal to 0. So first of all find the all index j that actually nums1 of j is less than of nums1 of index I. So first of all this 4, this is suppose our j is equal to 0. Is this valid? This 4 less than 4? No. So this is not valid. Next index j is equal to 1. Is this valid? This is value is 2. 2 less than 4? Yes, this is valid. So this is one valid index. Next is index this value index 2. Value is 1. 1 less than 4? Yes, this is valid. Next index is 3. 3 value is 5. 5 less than 4? No. Next index value is 3. Yes, index 4 and value is 3 less than 4? Yes. So this is a valid. So first of all, what is a valid j actually we actually found, that is j is equal to 1, 2, 4. These three index are valid. So we have to choose maximum two number from this index that actually give us the maximum sum. So for this index, what is the maximum sum or value is index 1, this value is 20. So I will actually get 20 if I add this. Next index 2 will give value as 30. Index 4 will give 40. So I can actually choose out of these three element maximum two element. So which actual element I can actually choose? Which two element actually I will choose maximum? Which will give the maximum value? So what is the maximum value actually here actually? 30 and 40. Correct? Sorry. 0, 1, 2, 3, 4. So index 4 value is 50. Correct? Index 4, 50. So which is the maximum two value? 30 and 50. So I'll get actually 80. You can see that for this index value is 80. Next for I is equal to 2. I is equal to I is equal to 1. We have to find out all j that actually n1 of index j is less than equal to n1 of index I. So index j, first of all j is equal to 0. Okay. So n1 1 value, index 1 value is 2 and j is equal to 0. For j is equal to 0, n1 0 value is, what is the value? 4. So 4 less than 2? No. So 0 is not a valid. Next j is equal to 1. So value is 2. 2 less than 2? No. So this is also not a valid. Next j is equal to 2. What is the value at index 2? That is 1. 1 less than 2? Yes. So this is a valid. So I will write down here. Next is j is equal to 3. Value is 5. 5 less than 2? No. So this is not a valid. Next is j is equal to 4. What is the value at index 4 in nums1? That is actually 3. So 3 less than 2? No. So only one actually index actually found, that actually valid, that actually 2. Correct? J is equal to 2. So I can actually choose maximum two element, two index, but here actually only one element, one index is present. So I will take only this element. So what is the value at index 2 in nums 2? 0, 1 to 30. 30. So you can see that for this index 1 the value is 30. But in this actually I have to calculate for each index. Now what is actually the brute force approach? So particularly for each I will actually check all j. Correct? Find out for each I, find all j where nums 1 of index j is less than nums 1 of index I. So I will get a list of index j. Correct? Now I will actually choose if I sort this, so I will corresponding to this index I will actually take the actually value in nums 2 from nums 2. Okay, suppose for index, suppose here actually 1 3 4 8, suppose I got this 4 index, so I'll check that what is the value at index 1 in nums 2. So I got suppose x, then actually I got y, then z, then a. Suppose I got actually this 4 value. Now I know that our k is equal to suppose 3, suppose. So what I will do, I will choose the maximum 3 value. So first of all I will sort this, I will sort this value because I have to maximize the sum. So I have to sort this in descending order. Suppose I got z a y x. Okay, this is actually the after sorting in ascending order. Okay, you can just sort it in descending also. If you descend the descending order, then actually it will be easy to take the left k most like left element, right? K element that is present in left side. So suppose here is k03. So this is actually sorting in the descending order, descending, not ascending, descending order. Then I will choose the maximum 3 element, this 3 element z plus a plus y. So this will be our answer. For this particular index I is equal to 0. Next, similarly for I is equal to 1, I will again actually first of all generate all the possible j actually valid, for actually nums 1 of j is less than nums 1 of I. Then I will actually generate another vector to corresponding value present in the nums 2. Then I will sort this in descending order. Then I will choose the maximum k element from left to right. Then I will actually add the sum and store into the answer vector, right? So here what are the time sorting? So first of all, each I, the range will be big of n, because particularly for each I actually I have to calculate. Then again I have to iterate whole in array, nums array, to check that which actually j index is valid for particular index I. So this will take big of n. Then we actually get suppose m valid index. Okay, so this to sort this array it will take m log n. Correct? Again we have to actually take the big of k to take the k element, k maximum element, maximum value element. So what is time sorted total? Just relate this big of n. This is for outer loop. Inside in this for loop we are actually trying to first of all trying to find out the all valid j. That's why I have to iterate the whole input array. Then actually I am sorting this m log m, then actually k to take the first k maximum element. So ultimately it will be n into n plus m log n plus k. So in the worst case it will take actually n square n into m log m maximum value. This is the maximum value m log m. Correct? So this will take big of n square log n into m into log n. This is clear. This is the brute force approach, and brute force approach is clear. If you any doubt, you will comment on that. Now, so this is obviously this will give us the TLE. Now, how can you optimize this? So, by using priority queue, we can actually optimize this. How? Suppose we actually what actually we are ultimately doing for particularly index I, we are trying to find out all the j that actually value is smaller than this I, nums 1 of particular index I. So if I actually try to calculate all from sorted order, like first of all I will check like if I sort the nums1 array with ascending order. So what will happen? First I will try to suppose I have sorted this nums1 array. So take this example again, 4 2 1 5 3. So here actually we know that we have to return the answer in a input order. Like first we have to return the order answer for the value 4, then I have to return for the 2. So we can't change the order, but we can actually change the calculation. How? First of all, I will, if I sort this array, so what will be the in array look like? 1 2 3 4 5. So first of all, check how many actually index are present in this j that actually less than 1. So there is previously there is no index j is empty. So what will do? There is no possibility to get any value. So our answer will be 0 here. Next is for 2. How many actually index are present? That is less than 2. Only one index, correct? And what is the value for this? Value is nums the index 1, not index 1, the 0 1 2, index of 1 is 2, and that corresponding value in nums2 is 30. So in this, for value 2 our answer will be 30. Okay, so this will be actually our 30, value 30. Next for 2, what is the value it was? Because next number actually I know it will be actually increasing. So next number for 2 value is 20, correct? 20. So next I will go to the value 3. So what is actually, how many index are actually there? They're actually less than 3. 2 index are there, 1 and 2. What is the sum of that? 30 plus 20. So previously it was 30 plus currently it will be added 20. So it will be 50. Next for 4. Now before going to the next index, next value, I have to store this value because I know that the next value will be always greater than the current value. So this 3 will be what? This 3 value is 50. So this will be added. 50 is added. Now go to the 4. So how many index are there? It is smaller than 4. 3 index are there. What actually value as a 1, 2 and 3. Clear? Now what is actually the maximum sum actually I can actually achieve? How many actually, what is the value of k here? K value is here actually 2. So but we actually have 3 valid index. So I will take only the maximum 2 value. So I will store this into the max heap. Correct? Max heap. Correct? So what I will do? I will actually take this, if I do the max heap, so it will store 50, 30, 20. So I will actually store this as a maximum k value is top k, sum of the top k elements is 80. So for this the value is 80. Similarly for going to the next value 5, I will store the for 4 also. For 4 the value is what? Value is 10. So I will store this into the priority queue. 10. So this actually 10 actually the smallest number, so it will store at the bottom. Now I go to the next index 5, next value 5. So how many index are there? That is less than 5. 4 index are there. So what is the maximum 2 elements will present? So maximum 2 elements again 80. So return 80. Now I know that what is the actual position of 5. So 5 actual position was this position. So I'll actually store this here. So size is 5, 1 2 3 4 5. So index 0 it is for 4, this is 80. Index 2 I have stored 30. Next is for 1 value is 0. 5, similarly for 5 80. For 3 value is 50. So now you should compare, this is your answer. Now you compare with the answer output, expected output. 80 30 0 80 50. 80 30 0 80 50. Got it? This is clear? That I will use a priority queue to store the get the maximum k element. And if size is already less than k, so we don't need to actually remove, because there is no option. Whatever the number is present, I can actually take. And why actually sorting the this nums1 array? To check whatever actually the number actually I processed before, that will be always less than the current number. So it will be always counted or the current search, our current search space. So that's why in this actually we optimize this, because whenever actually here actually what are doing, for it will take big of n to iterate from one number to next number. Each number actually I'm just going to, first of all, so we are sorting this, so this will take n log n to sort. Next, for each index, for each number actually I will check the how many actually smaller number actually present. So how will I check? I will check the from the priority queue that how many actually element are present. If it is less than k, so I will actually take all the number. If it is actually greater than k, then I will remove the smaller number, because I have to take only the maximum k element. So that's why I can actually, you can also take the mean heap and remove the minimum element that actually greater than k, if the size is, priority queue size is greater than k. So that's why this will be n into, for each number I actually go to k log k for priority queue, log k, no k log k, only log k, because I'm just actually popping the number that is greater than k. Got it? Constant. So this actually n log n, roughly we can say that this is to take n log n time. So now what is the code? So first of all, I have to sort the nums1. So I have taken a new vector. So I am storing what? The nums1 value at particular index I, and also the index, actual index, original index, because after sorting it may change actually the index. So that's why actually pair actually I created or actually stored the actual original index, and so sorted this vector that actually I have generated. Now what to do? I have to take a priority queue. So this priority queue will take what? Store the maximum k element, maximum value present in the our current search space. So I've taken two priority queue. I'll explain why. So this is one for the priority queue 1, another for priority queue 2. Okay. Now I have to take return an answer, vector of answer. So I know that the size will be always n. So I've initialized with n. Now I have taken a variable that will store the sum of the current number that is smaller than the current number. Okay. Sum of all the number. Now I have taken two priority queue. Second priority actually I have taken here, that is used to first of all check constant. So here actually number can be same. They have not mentioned that all the number actually distinct. Correct? So what will do? We have to find out the less than k, less than the current number. So we should not calculate the or count the index that actually equal to the current value. So that's why I actually discuss this. But next time, what actually, suppose I actually got this situation. Suppose 2, 2, 3. For these two, this is okay. For these two, should I calculate this index? No, because this is actually same. We have to calculate only less than, not equal to. So but for this is for this is okay. But for 3, we have to actually count these two index also, both the index. So that's why I have taken a priority queue that will store also the equals to also, if this is equals. So what I'll do, before I'll check that before going to the next index, next value, starting to the next value, I'll check that if a priority queue 2 is not empty, that means we actually have some element in the priority queue. So I'll check that the priority queue, the top element that is present in the priority queue 2, that is less than the current value, then this will actually this will should be counted. So I'll actually pop that and add into the priority queue 1, and also add the sum. Okay, whatever actually we are into the priority queue 1, that should be added into a sum. Okay, so I'm just popping from the priority queue 2 and adding into the priority queue 1. Now if till this while loop is run, it will actually check that which number actually perfectly less than the current number. I don't know there is any equal to or not, equal number or not, but whatever the number is less than, that already shifted to the priority queue 2, priority queue 1, sorry, shifted to priority queue 1 and removed from the priority queue 2. Okay, now I will check that what is the previous, I have not adjusted all the number that is less than the current number. Now what I have to do, I have to check that I have to take we have to take only the maximum k elements. Maximum k elements. So what to do, if a priority queue 1 size is greater than k, so I remove all the number that actually is minimum. So because I will take only the maximum k number, so that's why I check that if a priority queue 1 size is greater than k, remove from those number from the priority queue 1. So before removing, I have to adjust the sum also. So I'm removing from the sum. Sum minus is equal to the whatever top actually value is present, and priority queue 1 is the top pop. Here actually I have taken a mean here. So that's what are the minimum number is present at the top, that should be pop, only pop first. So in this, after this, it ensuring that what are the number is present in the priority queue 1, that is actually equals size is equals to 1, and also the number is less than the current value. Got it? Now we have to store the answer. So in the answer vector, particular index, original index, so what? The I dot second. In the pair I have stored this original index, second index, second element. So I'll store the actual sum actually I have currently. Now for the next, before going to the next number, I will first add this into the priority queue 2, not priority queue 1 directly. This priority queue 2 is the, you can say that this is a buffer. First of all, store this, and I will check the which number is currently valid for our current search space. How actually can valid this? I will check that which number is less than the current number, that will be actually a current valid. Got it? So what is the storing in the priority queue 2? The index value I dot first means the I dot first, it means what? I dot first means the value in nums1 that should be less than the current number, so I will store that, and also the corresponding nums2 value at particular index. I dot second, and the index will be get and value in the nums2 array. In this actually I will, for each index I will actually do that, and ultimately return the answer. So this is clear. I have shared this code in the description. If it is not clear, please replay the video again. So, and also you can actually check the code to better clarification. Thank you. See you in the next video.